And also in Tutor, they're going to be looking at solving simple trigonometric functions like these. Sine theta is constant, cosine theta, and tan theta. Alright, so any constant. And if it's not in that form, then rearrange it to put into that form. Alright? So easy to solve it, right? You just use the inverse function on your calculator. But the thing is, there is always more than one answer. Alright? If you look at the sine graph, the cosine graph, the tangent graph, they're continuous, right? They're never ending. Okay? The answer your calculator gives you are only in these ranges for the sine, cosine, and tangent. Alright? Because if you continue more than the range the calculator gives you, for different x values, you're gonna get the same y values. Alright? And that's what we mean by there is more than one answer. Same thing with the cosine graph and the tan graph. Alright? Now I'm going to show you how to find these other answers. Okay? Okay, so sine theta is 4/5. And it asks you to find all the answers, the possible solutions for theta within this range. They will always give you a range. Okay? This is the most common range between 0 and 360. Alright? And sometimes it's in radians. And they also, if it's not in exact values, they'll also tell you how to round it, so to three significant figures. So first of all, use the inverse sine function in the calculator, you get 53.1 to 3 significant figures. So if we sketch a graph, 4/5 is about there, alright? Inverse sine of that gave you 53.1. Are there any other answers between the range 0 and 360? Yes, there are. There's one here. If you continue the line, alright, there is another solution. Alright, how do we find it? We know the graph is symmetrical. If you look at my videos on the trigonometric graphs, I explain all that. So the distance here is exactly the same as the distance here. So to find this other solution, we just do 180 minus 53.1. And that's where the identity sine theta is equal to sine 180 minus theta comes from. Okay, so if you do that, that's going to give you 126.9 to 3 significant figures. Okay, and that's your other solution. So you write theta is equal to 53.1 degrees and 126.9 degrees. Okay, now you could sketch the graph and work out the other solutions like I just did right now, or you could use something called the unit circle, okay, which can prove more useful than sketching out the graph in full in some situations. I'm going to show you that right now. Okay, so this is the circle, alright, and we have 360 degrees or 0, and then we go to 90, then 180, then 270, and back to 360. Okay, if we draw a right angled triangle here, now the reason it's called a unit circle, okay, the reason it's called a unit circle is because the radius is 1. Okay? And if the radius is 1, alright, what is the x value and the y value for the lengths of the triangle? Alright? Sine theta, if that is theta, opposite over hypotenuse. So the height of the triangle is just sine theta. Cosine theta, adjacent over hypotenuse, so it's just cosine theta. So that gives you this triangle here. And that's where the fundamental trigonometric identity, sine squared theta plus cosine squared theta is 1 comes from, right? It's just Pythagoras. But that's not too important for solving equations. That's just so you can understand what the unit circle is. Okay. So CAST, alright, you can remember it as cast. Alright, in this quadrant, only cosine is positive, right? You see? In this quadrant, everything is positive. In this quadrant, only sine is positive. In this quadrant, only tan is positive. You'll get what I mean when we start solving the equation using the unit circle. Alright, so let's do it. Okay, so sine theta is 4/5. That is positive. So our right angled triangles will be drawn in the quadrants where sine is positive. Alright, it's positive here because everything is positive here. It's positive here because only sine is positive there. So yeah. So if we draw another triangle here, it's also going to be 53.1 degrees to one decimal place. The other solution is going to be this angle all the way up to the next triangle. How do we work out that angle? Well, it's a straight line first of all. Alright, so easy. 180 minus 53.1 gives you 126.9 to one decimal place. So basically the same thing you're doing when you're sketching the graph. Alright, you're finding the solution 180 minus theta. Okay, but visualize in a different way. Okay, so 0 to 360. Alright, these are the values in your range. Alright, you can't go here because they'll be negative and there's no solution there, there's no solution here. Alright, that's when the curve dips below the x-axis. Okay, but if you were to continue past 360, okay, so imagine the graph. Here is 360, then you continue, sign is positive again. Okay, so I'm just gonna sketch it out for you. You keep going to 360 and past the 360 mark up to the next triangle. So then your other solution, if you were to go past 360, would be 360 degrees, so one full turn, plus 53.1 degrees. Okay, same thing here. 53.1 degrees, 360 plus 53.1 degrees. Okay? So if you don't get the unit circle, it's okay. You need practice with it. Alright? It doesn't just come like that. And I found it confusing myself at first. You can just sketch the graph and do it that way. It's your preference, depending on the situation or blah blah blah. Whatever is easier. So, now it's your turn. Okay, cosine theta is equal to 1/3. Give me all the possible solutions with theta is smaller than or equal to pi over 2 and bigger than or equal to negative pi over 2. So, it's in radians, alright? And when you are dealing with radians, remember to change your calculator settings to radians. Otherwise, if you use trigonometric functions like sine, cosine, and tan, and it's not in radians, it's in degrees mode, you're going to get the answer wrong. All right? Let me show you. Okay, right now my calculator is in degrees mode because it says D right there. Okay, so to change the mode, you go to Shift, Setup, all right? Number 4, radians. Now it's in radians, okay? So sine of, let's say, pi over 2. That's going to give you 1, all right? It's the same as saying the sine of 90. Let's change that to degrees. Sine of 90. Okay? So remember to change your calculator to radians when you're dealing in radians and back to degrees when you're dealing in degrees. Your calculator might be different from mine, so figure it out. Okay, in the exam they're not going to give you something this easy, okay? I don't even need the graph or the unit circle because I know that in my head the cosine graph is symmetrical about x is equal to 0 and y is equal to 0, about the origin, okay? And so therefore, any value for theta that will be here will be the exact same value here, but negative, that'll give you the same y value. So cosine theta is equal to cosine negative theta. Alright, I know that. So I don't need the graph or the unit circle. But if you didn't know that, I would have sketched the graph for this one, because the range is not that big. So 1/3 is there. The calculator gives you 1.23 for inverse cosine in radians mode. Okay, so the other solution in the range will be here. Alright, because of the symmetry, the distance there is going to be the same distance here. So 0 plus 1.23, 0 minus 1.23, so your other solution is minus 1.23, to 3 significant figures. If you're using the unit circle, alright, in radians, pi over 2, instead of this being 270 degrees or 3 pi over 2, I'm going to get negative pi over 2. So you're going backwards, alright? Pi over 2, negative pi over 2. So your other triangle will be there, alright? 1/3 is positive, so where is the cosine positive? Here, because everything is positive in this quadrant, and cosine is also positive in this quadrant. Alright, so that will also be 1.23. So your other solution will be from the original angle all the way down to the next triangle. Okay? So that will be 1.23 take away 1.23 take away 1.23, which gives you negative 1.23. Clear? Okay? Okay, now try tan theta is equal to negative 9 over 4 within this range, and give all your answers where necessary to 2 decimal places. Go. Okay, so inverse tan of negative 9 quarters, remember to change your calculator settings back to degrees mode because it's in degrees, gives you negative 66.04 to 2 decimal places. Now the main thing about that is it's not in your range. Your calculator gave you this point. Remember when I showed you what limits the calculator gives you the answers for inverse sine, inverse cosine, inverse tan? Alright? It gave you this value. It's not going to give you this value because that's not registered on the calculator. Okay? So give the values that are in your range. That's going to be the point here and the point here. So, how to do that with the graph? Well, with the tan graph, it's really easy, okay? Because I know that this pattern repeats every 180 degrees. That's a fact. So that means any point here, if you add 180 degrees to it, it will be on the exact same point for this part of the graph, meaning it's going to give you the same y value. So to get from one point on the tan curve to the other, which gives you the same y value, you just add 180 degrees or take away 180 degrees. Alright? Which means that solving equations with tan is really easy. You don't need the graph, you don't need the unit circle, just add 180, or if you're in radians, add pi, and take away 180 or take away pi. And that's going to give you your next possible solution. Alright? But I'm just going to use the graph and unit circle just to help you visualize it. So getting at 180 degrees, alright, add 180 degrees. That's going to give you 113.96 2 decimal places and 293.96 to 2 decimal places. Now with the unit circle. So it's negative 66.04. Remember, this is now a negative value for tan. So only the quadrants where tan is negative. Alright, so the calculator gave you this one where it's negative 66.04. So that means this would be negative 90, not 270. Alright, I just put it there so you sort of get the idea. So this is not part of your unit circle. Okay, so it is not part of your unit circle because it's not in between the range. So the quadrants where tan is negative. Okay, the quadrants where, forget that. The quadrants where tan is negative. Alright, so here it's negative, here it's negative. It's positive here because everything's positive, and it's positive here because tan is positive in this quadrant. Alright, these are the two quadrants where tan is negative. So your first triangle that's in your range is this one. So from this angle all the way up to the next triangle, as you can see, you're just adding 180 degrees. Then your next solution that's within the range is this triangle, something that is actually in a unit circle, alright, but between 270 degrees and 360 degrees. So you continue all the way up to the next triangle, and again, you're just adding another 180 degrees. So that's all you have to do when you're solving tan theta is equal to something, alright, to get the other solutions. So your answers are 113.96 and 203.96, all to 2 decimal places. Alright? If your answer is not within the range like this, do not write it down as an answer. Okay? And also another thing, never round any numerical value that you're using in a calculation like this, never round it until the end. Okay? I rounded it here because I can't be bothered to write all the decimal places. Okay? But don't round it. Keep the value in your calculator. Alright? And then round these answers. Right? Because these are the final answers. In my next videos, I'll be looking at solving trigonometric functions that resemble transformation, so like tan 2 theta or tan theta minus 5, alright, within the brackets, and also solving quadratic trigonometric equations. Anyway, this has been the Awesome Tutor. Bye.